Next, we want to go to measures of dispersion, still using Pujols' home runs from the previous lesson. In statistics, measures of dispersion show how tightly spread out the data is in relation to a measure of central tendency. The main measures of dispersion are range, variance, and standard deviation. Range. Pujols' season totals varied from 17 up to 49, giving him a range, or a maximum minus minimum, of 32, which is actually a pretty wide range considering the low totals there. Broken into quartiles, the first quartile would be values less than 32, the second quartile ends at the median, 37, and the third quartile ends at 43. And the interquartile range is 43 minus 32 equals 11, meaning that 50% of the data is separated by 11. So how you find the different quartiles? Once again, we've already found our median, which is 37 right there. And then you find the median of the lower half, which here is 32, and you find the median of the upper half, which here is 43. So that's how you separate your quartiles. And you can see how half of the data is separated by 11. So it's really all pretty close from there to there. So that is your range and looking at quartiles. Next we'll look at variance and standard deviation. Here is the formula to find your variance, s squared. This symbol equals summation, which means the sum of every term in the equation after the summation sign. So what that means is this number represents every term in the set. So you have to you take every term in the set. So one season he had 17 home runs, and you subtract it by the mean, which was 36.8. So if you take 17 minus 36.8 and find the square of that number, and do that for each of his 14 seasons, and then you add all of those numbers together. We'll show you that on the next slide. The variance is the sum of the squared difference between each number and the mean divided by the total items in the set. So we are looking at Albert Pujols' home run variance using, of course, the data set that we had previously. Those are all of his home runs. The average, or the mean, 36.8 per year. So you take each difference, square it, and average the result. So 37 minus 36.8 is 0.2. 34 minus 36.8 is 0.28, negative 2.8, and so on, and you square each one of those. So 2/10 squared would be 0.04. Negative 2.8 squared would be 7.84, and so on, as you can see there. And then you add all of those together to get 931.52 and divide that by 14. So he has a variance of 66.54, which in this case is actually a pretty wide variance. To find the standard deviation, you take the square root of the variance. And in this case, the standard deviation is 8.16. So we're going to look at Chebyshev's rule, and this is where standard deviation really comes in and is important. According to Chebyshev's rule, for a data set that does not follow a bell curve, at least 95% of the data will fall within 2 standard deviations of the mean, and at least 99.4% will fall within 3. Again, with Pujols' home run totals, we actually have a pretty small data set, but his mean or average home run totals are 36.8. Standard deviation is 8.6. So one standard deviation would be, 8 above that. So at 44, almost 45, one standard deviation below would be 28, really just under 29. And then you do subtract another 8 or add another 8 there. So 95% of his home run totals should be 20.48 up to 53.12. In fact, just 1 year falls outside of that range, 2013's 17 total home runs. So again, that really pops out as an outlier, and then what you would do as a statistical researcher, and what we will talk about in class, is you'd look at that and say, well, why did he only have 17 home runs in 2013? All right, this lesson will also be posted online in PDF form. Take a look, and we will see you on Monday. And if you have any questions, we can go over them on Monday, and we'll do some work with mean, median, mode, and standard deviation in class.